Hello everyone. Am I audible?
Hello, sir.
Hello Krishna. Hamza, Shikani,
Good evening, sir.
good evening. Any doubts from the last classes?
No, sir.
No, all right. You all remember how to multiply matrices and all?
Yes, sir.
All right. Let's start with few difficult questions on that. All right. Not that difficult, but few tricky ones. All right. We did easy questions in the last classes. Right. If 2, 3, 4, 5, 2, 1 times A is equals to 1, 3, 2, 2, 5, 1, 15, 3, 2. I think I did gave you this question for homework. Did anyone solve this question? Krishna, Hamza, Shikani.
No, sir. I haven't solved.
All right, solve it now then. We only discussed what will be the order of A, right? We did not discuss the answer.
Yes, sir.
All right, so please find the answer now. All right, Hamza, is this clear?
Yes, sir.
All right, solve it. Tell me the answer. All right, I'll give you a few minutes. How to solve? You have to assume a matrix A, right? And we all know the order of matrix A, I hope.
Sir, what is A with arrow downwards?
How to? We discussed in the last class. See, this matrix is 2 by 3. Sorry, 3 by 2. 3 rows and 2 columns. So multiplication is possible. That means this must be 2 cross something P, and the resultant matrix is 3 by 3. So this will be 3 by 3. That means P is 3. So assume a matrix A of order 2 by 3. All right, 2 rows and 3 columns. So we can assume A, B, C, D, E, F. All right, 2 rows and 3 columns. All right. Hello, Rishan. How are you? Did you watch all the lectures? All right then. Try to solve this question, Rishan. All right, we have to find the matrix A. Assume the matrix A as this. Find all the alphabets. 1 or 2 left. Then this will be a trouble to solve, I hope. I think. All right. Do you know how to multiply, Rishan? 2 matrices? All right, no worries. But try to keep it up. All right, try to keep it up with the lectures. All right. You can try this one. Otherwise, I'm going to solve this in a few minutes after everyone solve this. All right.
Sir, is D minus 7?
Let me check. Give me a minute.
I got D as minus 7.
We got the value of D is which see, you must have three equations in this question, right?
Yes.
So which equations did you take? That depends on the answer, right? The answer depends on that.
I took 1 1 and 1 3.
1 3, right? So I have a different answer here. All right. The purpose of solving this question is to teach you something else. All right. You all know how to solve equations. Let me solve it. Give me a minute. This is 2 3 4 5 2 1 multiplied by A B C D. Sorry, A B C D E F. All right. So here, what we'll have 2A plus 3D, right? And this is 2B plus 3E, 2C plus 3F, 4A plus 5D, 4B plus 5E, 4C plus 5F. 5F. This is 2A plus D, 2B plus E, and 2C plus F. Right. Now see, to solve A and D, to solve for A and D, you can take any of these three equations, right? You can take these two, or these two.
Yes, I took
You'll get.
the last one.
All right, Shikhani, there is a lot of disturbances, all right, background noise.
Sir, I was saying I took the first one and the last one.
Last one, all right. Krishna, what about you?
Yes, sir. First one and the last one.
All right, and Hamza?
Sir, in all the cases, I have taken first one and the last one.
All right. See, when you solve, suppose you solve these two, all right, and you get some answer. After you get that answer, you have to put that in this equation also. So this should also satisfy this equation. All right, we cannot take any two equations and say that is the answer. All right, you have to take two equations, solve, then put the answer in this equation, and that answer should satisfy this equation also. Is this clear?
Yes, sir.
Otherwise, we will say there is no solution because we have to satisfy all these three equations. All right.
Yes, sir.
So whatever answer you have, all right. Suppose D is -7. Is D -7?
Yes,
Yes,
I
sir.
got -7.
All right. And the value of A is
A is 11.
11. So let's put that in this equation. So this is 44 minus 35, and this is 9. And in the question we have 2.
Yeah.
So this answer doesn't satisfy equation 2, right?
Yeah, it doesn't.
Yes, sir.
So this is not a solution for this matrix. This way you have to solve. All right, you can take any two, it doesn't matter. You can take any two, but that answer must satisfy the third equation also. All right.
Yes, sir.
Yes, sir.
All right. So in this question we'll write there is no solution for A and D, and you have to solve this for B, E, C, F also. All right.
Yes, sir.
Yes, sir.
All right. We'll solve another question of this type. Just to be clear. All right. Write down.
Sir, so what should we give as the answer for that?
We will write for A and D there is no solution for A and D. All right. And if this case remains for B, C, D, E, then you will write no solutions for this matrix. All right. All right. prove that the product of these matrices cos square theta, cos theta sin theta, cos theta sin theta, and sin square theta, and cos square phi, cos phi sin phi, cos phi sin phi, and sin square phi. All right, this is theta, this is phi. If you are not comfortable with phi, then you can replace phi by alpha. All right, no worries. That's the null matrix. When theta and phi differ by an odd multiple of pi by. All right, they are saying, write down the question first. All right, I'll explain. Tell me when you are done writing.
Done, sir.
All right, the question is saying that the product of this matrices, that means you have to multiply these two, that results in a null matrix when this is the condition, when theta and phi and the difference of them is an odd multiple of pi by 2. Odd multiple of pi by 2 means either pi by 2, 3 pi by 2, 5 pi by 2, and so on. Right? When they differ by this value, and differ by means theta minus phi, you should be getting either pi by 2, 3 pi by 2, or something like that. If that is the case, then the resultant will have a null matrix. Is this question clear?
Yes, sir.
All right. So the first step is to multiply. So try multiplying this with this. All right. And then simplifying. All right. After simplifying, compare with a null matrix and see what you get as the result. All right. The steps are clear. Krishna, Shikani, Hamza.
Yes, sir.
Yes, sir.
All right.
Sir, done.
All right. Getting this answer, the theta minus phi should be
No, sir, I did not do the answer, sir. Just
you
multiply.
multiplied.
Yeah.
All right. All right. Krishna, what about you?
Sir, still doing so.
Still doing. All right. Shekhani, now you can compare. All right. Take each element. Suppose you get A, B, C, D. We should be getting A as 0, right?
Yes.
So now you can compare the value of A with 0. All right. You need a little bit trigonometry. Have you guys started doing trigonometry questions?
Inverse trigonometry.
No, trigonometry. I told you in the last class, start 11th class NCRT trigonometry.
Oh yes, yes, yes. I'm doing that since the beginning of the.
All right, all right. So you need a little bit trigonometry for this question, right? So please try to simplify first the multiplication, then compare with 0.
Sir, I want to know this. My multiplication is right.
Multiplication, for that I have to actually write the answer. Give me 2 minutes. All right. After everyone solves,
Okay, sir. Okay.
I'll explain. All right.
So can you solve this question?
All right. Let's see. We have cos square theta, here cos theta sin theta. What is the term here? Cos theta or sin theta?
Cos theta sin theta.
Cos theta sin
Cos
theta.
theta.
The next one
And
is
this
sin square theta.
sin square theta. All right. You guys okay with me writing in phi, or shall we change this into alpha?
You can write cos square x.
Cos square x. All right. Let's write cos square x, and this is cos x sin x.
Yes, cos x sin x. And then again cos x sin x.
All right.
And then sin square x.
Sin square x. So let's multiply. Shekhani, this row and this column, right?
Yes, it will become cos square theta into cos square x plus cos theta into sin theta into cos x into sin x.
All right.
And then it will become cos theta.
Cos square theta, cos x sin x, right? This
Yes.
row and this column. So cos square theta, cos x sin x plus this into this. So sin square x, cos theta, sin theta.
Yes.
Now this row and first column. So this I guess is repeating cos square x cos theta sin theta plus sin square theta cos x sin x, and this is cos theta sin theta cos x sin x plus sin square theta and sin square x, right?
Yes, sir.
All right. Now you can see if anything is common, you can take out common things. All right, take out anything that is common from here. Cos theta and cos x we can take common, right? So this will be cos theta cos x in brackets cos theta cos x plus sin theta sin x. Is this right?
Yes, sir.
Yes, sir.
All right. From here, what is the common part? One is cos theta, I guess. Another is sin x, right?
Yes, sir.
Yes.
Cos theta sin x. What it means is cos theta cos x.
Cos x sin x.
Yes, sin x and sin theta also.
Yes.
All right. From here, what is common? Cos x and sin theta. So cos x and sin theta. Here cos x cos theta plus sin theta sin x.
And also cos x.
Right, cos x. No, cos x is not here. Right. So we can take sin x, sin theta, we can take common, right? Because this is sin square theta, sin square x. So sin theta, sin x we can take common. So cos theta, cos x plus sin theta, sin x, right? Everyone, this is clear?
Yes, sir.
All right. Now, who can tell me the formula for cos A, cos B plus sin A, sin B? Anyone who knows the formula for cos A, cos B, sin A, sin B will win a 20 rupees Dairy Milk chocolate from me. No one?
No, sir.
Sir, it is, I think, sin A plus B.
Sin A plus B. All right. No. All right. You all lost a chocolate today. So this is cos A minus B. All right. How to remember the formula? And I'm telling you again, start doing trigonometry from 11 NCERT. Otherwise, integration will be very difficult for me to teach and for you to learn. All right. We only have to do then formulas for trigonometry. See how to remember this formula. If cos cos sin sin. All right. If cos cos sin sin, then this is a formula for cos either A plus B or A minus B. Is this clear? If
Yes, sir.
cos cos sin sin, then either A plus B, A minus B. Now which one is this? Here plus sign is there, that means minus. If negative sign is there, then plus. This is clear?
Yes, sir.
All right. Now if you have sin cos cos sin, then this is the formula for sin. And in sin, if this is plus, then A plus B. All right, that means sin A cos B plus cos A sin B will be sin A plus B. Will you remember now?
Yes, sir.
All right, same for subtraction. If you have sin A minus B, then this will be only negative sign. Nothing else will change. All right, now I hope you will remember this formula till eternity. All right, now we can change this. This is cos theta cos x sin theta sin x. That means this is cos of theta minus x, right? Cos A minus B.
Yes.
Yes, sir.
All right. Same for this. This is cos theta cos x sin theta sin x. So cos of theta minus x. Same here, cos x, cos theta, sin x. So cos theta minus x. And this is also, I guess, cos theta cos x, sin x. So this is cos of theta minus x. So now we can see this cos of theta minus x is common in all the elements. This is clear?
Yes, sir.
All right. So I can take this common element out of the matrix. We can write cos of theta minus x, and in the matrix we have cos theta cos x, cos theta sin x, cos x sin theta, and this is sin theta sin x. All right. This step is clear, everyone?
Yes, sir.
All right. Now this is equals to a null matrix they are saying. All right. So that means this quantity must be 0, right? For each of them to be 0, this must be 0.
Yes, sir.
Is this clear? So we can say that.
Sir, one question: how did cos into theta minus x come out?
We know that if you multiply 2 in a matrix, then this 2 is multiplied in each of this term.
Yes.
Right. So now if you look at this matrix, cos theta minus x was multiplied in each of this term, right?
Yes.
So I can take the reverse order. I can take this cos theta minus x out of this matrix. All right, Shekani?
Yes.
Absolutely clear, right?
Yes.
All right. So now we know this must be equal to 0. So cos theta minus x must be equal to 0. Now I hope you remember this also for class 11, that if cos of some angle alpha is 0, then this alpha must be equal to some odd multiple of pi by 2, n pi by 2, right? Because cos 90 degrees is 0,
Yes, sir.
right? And cos 270 degrees is 0, if you remember.
Yes.
So whenever cos of some angle is 0, that means that angle is a odd multiple of pi by 2. All right, you can write it down also if you want. If cos of some alpha is 0, then alpha must be equal to the n pi by 2, where n is an integer. All right, odd integer. Or you can write 2n plus 1 pi by 2. 2n plus 1 pi by 2, where n is an integer. All right, so we can say theta minus x is odd multiple of pi by 2. Is this clear, the trigonometry part, everyone?
Yes,
The
sir.
last part is not clear, sir.
Not clear, Shikani?
Yes.
Are you saying this is clear or not clear?
No, not clear.
Not clear. All right. Which part? This part? 0 part?
Yes.
All right. Let me explain in some clear handwriting. Shekani, do you remember the values for cos? Cos 0 is?
Cos 0, I don't remember. 1, I guess.
1, right? Cos 45 is?
I don't remember. I have to write the table.
1 by root 2. All right. Cos 90 is?
That
0.
also.
All right. Cos 90 is 0.
0.
And 90 we say pi by 2. 45 is pi by 4. 0 is 0.
0.
Now, if you remember little bit, in trigonometry in class 11, we did this circle thing, right? You move from here, this is pi by 2, this is pi, this is 3 pi by 2, and so on, right? Remember this, cos becomes 0 in vertical lines. All right, in y-axis, whenever you reach to the y-axis, cos will become 0. So this is pi by 2. If you move from here to here, this is 3 pi by 2, because how much you are moving? You are moving a pi degree. So pi plus pi by 2 is 3 pi by 2. Same if you move again, you are moving from 3 pi by 2 plus pi, right? Pi by 2, right? So you can see this is odd multiples of pi by 2.
Yes.
So on odd multiples of pi by 2, cos becomes 0. All right, cos becomes 0. Is this clear?
Yes.
So whenever you see some angle of cos is 0, that means this angle must be equals to odd multiples of pi by 2. All right,
Yes.
and this means you put the value of n and you will get different values for x. All right,
Yes.
in the same way we had the question cos theta minus x is equals to 0. So this theta minus x must be odd multiples of pi by 2, which is the question. All right.
Yes. Yes, sir.
All right. Now you can see this value satisfies all these terms. This, right? So this is the solution for this. If you had to solve for different elements, suppose you would get this value for this one, but not for this one, then there will be no solution. All right. But you can see this solution satisfies all these elements, right?
Yes, sir.
All right. Is this a difficult question? You find it difficult because of the trigonometry?
Yes, sir. Very difficult.
I feel so. थोड़ा थोड़ा सर में ऐसे दर्द.
Yes.
I know.
Sir,
I
can
can
you
feel
check
that.
the second row, second column, sir, the element 2, 2.
Second row, you can say A12 or A21 like that.
Yes, sir, A22.
A22. This one, I wrote this one wrong. Like the multiplication part is wrong or which part?
I think it's multiplication, sir.
All right, let's see. We have cos theta sin theta cosec sin x plus sin square theta into sin square x. So I think no, it is right. Cos theta sin theta cosec sin x plus sin square theta sin square x.
So, but how
Second.
did you take common cos theta sin square theta? Because they in the
we have sin theta cos x sin x plus sin square theta and sin x sin square x, right? See, one sin theta is common, one sin x is common. So if
yes,
you
sir.
take sin theta sin x, what remains here? Cos theta and cos x plus
Yes, sir.
here sin theta and sin x. All right.
Oh, okay, sir, I got it.
All right. Do you guys need time to note it down, or shall we move ahead?
Then we'll move ahead
So-
because this question is very difficult.
Yeah, see, in boards they will probably give you trigonometric or the question I'm going to give you next. All right, so please be comfortable with trigonometry.
Sir, can you
I'm-
give time to note this down, sir?
All right. Let me start with on the first page. Very important questions these are. All right, Shekhani,
Yes, sir.
start doing trigonometry from class 11th. All right, otherwise,
Yes, sir, I'm doing that.
yeah, future is very dark. All right.
Yes, sir.
Okay, note it down.
Sir, I think the last term you took common as sin theta and sin x, right?
Right, sin theta and sin x.
Sir, but how can you take common as cos theta and cos x? cos, yeah.
No, see, in the last A22, right?
Yes, sir.
See, we had this term, right, Krishna?
Yes,
This
sir.
term you are getting. Now
Yes.
look at this. We have sine square theta and sine square x, and in here we have sine theta, sine x. So I took sine theta, sine x common. All
Yes,
right.
sir.
So from here, if you remove sine theta, sine x, what is remaining? Cos theta, cos x. And this is plus sine. And if you remove sine theta, sine x from here, what will remain? Sine theta, sine x. Because we have two of them here. All right.
Yes, sir. But how did you take the whole common, sir? Like common from
Common
whole
from the
matrix?
matrix.
Yes, sir.
All right. See, this is sine theta, sine x. This is the same formula for cos of theta minus x.
Yes, sir.
So these three terms are multiplied together, and this
Yes.
element is common in all the four elements.
Okay. Okay, sir. Got it. Thank you, sir.
All right.
So can you scroll up?
Give me a minute. The pen tab is scrolling up or down. I don't know. Yeah, up. Noted this down.
So, Ronald, can you do a little bit of?
All right.
Okay.
Is it okay?
Yes, yes.
All right. Note it down.
Yes, sir.
All right. Now let's learn something new. Right. You remember there was a chapter called complex numbers in 11th?
Yes,
Yes.
sir.
Right. There is a thing called cube root of unity. Anyone knows about this?
Root of complex numbers.
Shikhani, your voice is very low. They wrote this as omega. You must have seen somewhere omega square like this. Like these are called the cube root of unity. All right. What this means is, if you have a equation 1, all right, some x cube equals to 1, then what are the cube roots of 1? That we need to find out, and we name them 1, omega, and omega square. How can you solve this? You just take x is cube root of this, and this is 1, so x equals to 1, we say, right?
Yes, sir.
Yeah, but this is wrong. Not wrong, but incomplete. All right, because we know anything that has power 3 or degree 3, that means we must have 3 roots for this, right? Any cubic equation has 3 roots, but we only wrote 1 root, so we missed 2 roots. How to find those 2 roots? We have the equation x cube minus 1 is equals to 0. We can take this one to this side. Now anyone who can tell me a cube minus b cube formula?
So which formula?
A cube minus b cube.
Sir, a cube minus b cube in minus 3ab a plus b.
Okay, we start with minus 3ab.
Sir, the a plus b into a square minus ab plus b square.
Absolutely right, but that is the formula for a cube plus b cube.
Then what do you want? Minus. Oh, then it's like that. A minus b into a square plus ab minus
Plus b square.
no plus b square. Yes.
All right, when we have minus, then the minus is just here, a minus b, everything else is positive. If we have plus here, then this is plus, the ab terms is negative. Very important formula, write it down. All this formula in integration we will use continuously. All right, write it down. So now we can apply this. This is x cube minus 1 cube. So this is x minus 1, x square plus x plus 1 equals to 0. Now we can say either x minus 1 is 0 or x square plus x plus 1 is equals to 0, right?
Yes.
All right. So from here we can say x is equals to 1, but this equation is also there. So this is x square plus x plus 1 is equals to 0. Now we cannot solve this using middle term splitting, which you know from class 8, I guess. How we can solve? We can use the quadratic formula. Anyone knows the quadratic formula?
Sir, negative b plus minus root b square minus 4ac by 2a.
Absolutely right. So we can apply this formula here. So we can write x is equals to minus b. So minus 1 plus minus b square, that is 1 minus 4ac. So 4 into 1 is 4 upon 2a. So 2. So this is minus 1 plus minus negative of 3. This is why this is called complex root of unity. All right. So 1 plus, once you take this minus 1 plus negative root 3 by 2, and this is called omega. We write that as w, small w. And if you take negative, this is called omega square. All right. These three are called cube root of unity. 1, omega and omega square. Is this clear?
Yes, sir.
Write it down. Alright, we can write this in easy form also. -1 plus, we know negative of under root of -1 is I, so this is root 3I by 2.
Sir, I don't
I, if you
understand how. I
which part?
kind of forgot complex numbers.
Which part you didn't understand? This step?
The complex number, adding that complex number. Multiplying
This one.
complex number. Yes.
All right, let's see. Minus root 3 under root. Can I write this as -1 into 3? Right? I can write this like. So this is under root -1 into under root 3. I can take this into two parts. Is this clear?
Yes.
And under root of -1 is I.
I. So root 3I. That's right.
All right.
Yes.
So this we know now. 1 omega and omega square are cube root of unity. Two things you need to know about them to solve the next question. One is omega cube will give 1, obviously, because omega is a cube root of unity. So omega cube will give 1. Second one is 1 plus omega square is 0. You can add and you will see this is true. All right, we will not waste more time on this. You can just add, put the value of omega square and 1. You will see, you will get 0. All right,
Yes, sir.
write these two very important things. So let's start the next question. If omega is a complex cube root of unity, show that 1 omega square 1 omega square 1 omega plus omega square 1 omega square 1 omega square 1 multiplied by 1 omega square is equals to 0, 0, 0. All right, this you have to prove. Start with LHS, multiply these two, then add. We'll see what answer you get. All right.
Yes, sir.
All right.
So first we multiply, then we add, right?
Right, because this multiplication comes first. Actually, in the question, I forgot. I didn't see. There is a bracket here. So first you have to add. All right, there is a bracket. First add, then multiply. All right.
So what?
There is a brackets here. So you have to first add. I forgot to see the bracket. All right.
Not do board mass.
Sorry.
So we'll not do board mass.
No. You don't use that now because the brackets come first, right? In board mass also, brackets
Okay.
comes first. So you have to simplify the addition part first, then multiply.
Sir, I got the answer.
All right, you are getting 0.
No, not that. I did the multiplication and addition.
All right, you can check. You can use this formula, and you will get 0. Everyone solve this.
Just 1 minute, sir.
All right.
Yes, I am getting 0.
All right. Let's see how we can solve this. If you add these two, you are getting 1 plus omega, omega plus omega square, 1 plus omega square. And this is omega plus omega square plus 1, 1 plus omega.
Plus omega. Omega square plus omega.
Omega square plus
And then 1 plus omega square. Then 1 plus omega.
right? And this is 1 omega omega square. All right. Now see, we have the identity 1 plus omega omega square is equal to 0. 1 plus omega we can write minus of omega square. Right, Shekani?
We will not multiply.
No, we are not multiplying yet. We can just replace this value with minus omega square.
How?
Right? 1 plus omega square is 0. That means 1 plus omega is minus omega square.
Square, yes.
So this is minus omega square. And this we can replace with minus 1. This we can replace with minus omega. And so on for each quantity. So this is minus 1 minus omega square. This is minus 1 again, I think. All right, this is all right. So 1 plus omega square is minus omega. This is minus omega square. All right. Now negative 1 is multiplied in all the quantities. So we can take negative 1 outside of this. What we are getting is omega square 1 omega omega square 1 omega square 1 omega square. All right. Now we can multiply, and you will see the answer we are getting is 0. Sorry for my this diagonal handwriting. So this is omega square and plus omega cube. Right. Now for the second element, this is 1 plus omega square plus omega raised to the power 4. And for this, we have 1 plus omega square plus omega raised to the power 4. All right, Shekani, this is clear.
Yes, sir.
Now, omega cube is 1. I told you omega cube is 1. So this is 1 plus omega square. So this is 0. Now here, if you look at omega raised to the power 4. So this we can write omega cube into omega. Omega cube is 1. So omega raised to the power 4 is omega only. Now 1 plus omega square is 0. Same for this one. So minus 1 into 0, 0, 0 is 0, 0, 0. All right.
Sir,
Yes, sir.
omega raised to 4 is what?
Omega. Why? See, omega raised to the power 4 is, we can write omega cube into omega. Right?
Yes.
Omega cube is 1.
How is omega cube 1?
Because omega is the cube root of unity. I told you here, see. What is omega? Omega is the cube root of unity. See, here I told you omega cube is 1. Why? Because if you take root of 1, what we get? 1 omega omega square. So omega cube is 1. All right. Shikhani, this is clear?
Yes.
All right. So this way you can prove this is equal to 0, 0 and 0. All right. This question is clear, everyone?
Yes, sir.
Yes, sir.
All right. Let's have few more questions based on. You can write questions based on matrix polynomial equations. Right. Let's see one question. Let f of x is equals to x square minus 5x plus 6. Find f of a if a is equals to 2, 0, 1, 2, 1, 3, 1, minus 1 and 0. Write it down. I'll explain how to solve. Done.
Yes, sir.
Yes, sir.
All right. Shikani, what if I ask you f of 1? How would you solve?
F of 1. We'll
Yes.
put that in x.
Right. So this is 1 square minus 5 plus 6. Right. So you will say 2 is the answer.
Yes.
So for f of 2 and f of 3, we can solve, right?
Yes, we can.
They are simply asking f of a. That means you will put the value of a in x. Right. If they ask you f of 1, you put x equals to 1. If they ask f of 2, you put x equals to 2. If they ask f of a, then put x equals to a. Right.
Yes, sir.
So f of a will become a square minus 5a plus 6i. This is a crucial step. All right.
What is
6i.
I?
This I is the identity matrix. All right. You remember identity matrix 1, 1, 1, 0, 0, 0, 0, 0. But diagonal elements are 1.
Diagonal elements are 1.
All right. And this order of this matrix will become the same as A. All right. And you can solve this very easily. We know how to find a square. We know how to find 5a. We know how to find 6i. All right. Try to solve now.
Yes, sir.
Done, sir.
All right, got the answer?
Yes.
Let's see. This is 2 0 1 2 1 3 1 minus 1 0. All right, a square will be 2 0 1 2 1 3 1 minus 1 0. So this is 4 and 5 0 0 minus 1 2 and 0 2, and this will be 4 to 6 1 7 0 1 minus 3 minus 2 5 0 minus 1 1 minus 3 minus 2. Is this right?
Yes, sir.
A square we are getting
1 should be 4 plus 6, right?
a 1 1. This element you are saying
Yes, it should be 4 plus
2
6.
into 2 into 2 4 and 0 into 2, right? This row and this column. Shekhani, you always take this,
No, sir. That would definitely.
right? So see, 2 into 2 4, 0 into 2 is 0.
Yeah.
All right, 1 into 1 is 1, so 4 plus 1 is 5.
Yeah.
All right,
Oh wait, I wrote. Okay, I know that.
all right. So now we can find 5a. 5a is 5 times 2 0 1 2 1 3 1 minus 1 0. So this is 10 0 5 10 5 15 5 minus 5 and 0. All right, and 6i. Let's write the equation. We have a square minus 5a plus 6i. So a square is 5 minus 1 2 7 minus 2 5 and 0 minus 1 minus 2 minus 5a. So this is 10 0 5 10 5 15 5 minus 5 0 plus 6i. So 6 times 1 0 0 0 1 0 0 0 1.
Sir, I think a 2 1 is 9, right?
A
For
2
the a
1
square.
is
For a square.
this. Let's see, 2 1. So second row, first column, 2 4 plus 2 6 plus 3 9, right? Absolutely right. Did I do this whole row wrong? 2 0 1 minus 3 minus 2 2 and 1 3 5. And this is 0 5. All right. That only that element wrong is wrong, right?
Yes, sir.
Yes, sir.
All right. All right. So this is 9. All right. Now we can subtract. This is 5 minus 10 is minus 5 minus 1 minus 0 is minus 1 2 minus 5 is minus 3 9 minus 10 is minus 1. This is minus 2 minus 2 minus 5 is minus 7 5 minus 15 is minus 10 0 minus 5 is minus 5. This is plus 5, so 4 minus 2 minus 0 minus 2. All right, we'll add 6i. That means this is, I'm writing this here. So this is 6 0 0 0 6 0 0 0 6. If you add this two, you will get the final answer. All right, so this is 1 minus 1 minus 3 minus 1 minus 1 minus 10 0 sorry minus 5 4 and 4. Is this clear?
Yes,
This is the
sir.
answer. All right.
Yes.
Shikani,
Yes, sir.
All right. So as you can see, this is very lengthy calculations, right? Because the chapter matrix is very easy. The processes are very easy, right? Suppose in your history exam, you don't know the answer. So what you do is you write in very bad handwriting. So the teacher is very difficult, getting very difficult to read, right? So that's he awards some marks. The
Yes.
same way the teacher do the same in this chapter. The processes is very easy. So what they do is make the calculations very hard, right? Put trigonometry into this or omega into this so that you guys get confused. All right.
Yes, sir.
So
Yes,
what
sir.
we have to remember is do the calculations very calmly. All right. You can see even I make mistakes. All right.
Yes, sir.
So try to be as calm as possible and do this very slowly. All right. So this is all for today's class. I hope no doubts here.
No, sir.
No doubt, sir.
All right. And again, start doing trigonometries, right? All the formulas, very important. All right.
Okay, sir.
All right, then see you in the next class.
Thank you, sir.
All
Thank you,
right.
sir.
Take care.